Algebra 2, Chapter 3.2, Writing Quadratic Functions. We have our essential question: what information identifies the parameters for writing a quadratic function in vertex form? Well, there are two different scenarios. The one we're going to call A, scenario A, is where you have a vertex plus one other point. And then scenario B, where you're going to require to have an axis of symmetry, know whether the parabola opens upward or downward, and then two other points. And we're going to examine these different scenarios how to write a quadratic function in vertex form. Explore. So we have a given parabola has an axis of symmetry of x equals 1 range of negative infinity to 4 opens downward. And the very fact that we have that range would indicate that we have a downward opening parabola. What this information tells you can use to write the equation of the quadratic function in vertex form. Well, the parabola opens downward. What do you know about the value of a in the equation of parabola? Insert less than, greater than, or equal. Well, a is going to have to be less than 0 for a parabola open downward. B, the axis of symmetry is x equals 1. What does it tell you about the vertex of the parabola? Well, it tells you that the x value of that vertex is 1. C, the range of the parabola is greater than negative infinity less than 4. Actually, it should be actually less than or equal to 4. What does it tell you about the vertex of the parabola? The y value of the parabola is 4. Of the vertex of the parabola is 4. Next, what other value do you need to write the equation of the parabola in vertex form? Well, we need to find what a is. We already have the, for instance, if we have the form here, we know that a is going to be negative. We don't know what a is, but we know that we have x and we have 1, x minus 1 squared, plus 4. So we know that much, but we don't know yet what a is. So we need to know the value of a. And once we have the value of a, we can just fill in a for this question mark. Suppose the range was greater than 4 and less than infinity, and the parabola opened upward. What would be different about the equation of the parabola? What would be the same? Well, it would be f of x equals, we would have a, this time we know a would be positive, we would have x minus 1 still, the x value is that, and then we have plus 4. So a would be a positive number. I'll just say be positive. And everything else would be more or less the same. So let's go ahead to the next thing. Explain one, writing the quadratic function given parabola's vertex, direction of opening, and another point. And that's kind of what we talked about. In fact, it says another point you could get from you can get the direction of opening from what that other point is. Because the other point is above the vertex, we know that's upward opening parabola. If the other point is below the vertex, we know that's a downward opening parabola. Okay, so we have all this information. I'm just going to go on. And here's a example 1, use vertex direction opening another point in parabola to write the equation. So we're given this vertex of 3, 2, and another point, and it says opening downward. Let's say we didn't even know that. Okay, here's the vertex at 3, 2, and then the other point is 5, -6. Is this -6? Is -6 less than 2? Yes. So downward opening parabola. So we didn't have to know upward or downward. Okay, first identify h and k from the vertex. And we have h equals 3, k equals 2. And then we substitute in h for k, 2, 3 for h, 2 for k. And then we substitute that other point in here. And what is the other point? The other point is 5, -6. So here's our -6. And here's our x value 5. And then from here, we just simplify until we derive what a is. We come down to a equaling -2. And so we know that our vertex form of the equation is this one below. Fx equals -2 times 20x minus 3 squared plus 2. Next, it's another example, but one for us to fill in the blanks. Okay, so you can just stop the video and try to do this, and then work ahead, see if you got it right. Okay, h equals -1, k equals 5, and then we have fx, substitute h and k from the vertex, form of a quadratic equation. So we have x minus -1, and over here plus 5. So substitute the other point to solve here. So we're going to put the 0, 8. So the 8 is going to go right here. The 0 is going to go in place of the x. So we'll have 0, and we have minus -1, that's going to be plus 1. And then we have plus 5 over here, and then 8 goes over here. So now we just go ahead and write this out. 8 is equal to 0 plus 1 squared. That's going to be 1 squared plus 5. And so we have 8 equals 1a plus 5. And then we subtract 3. So 3 is equal to 1a. So a is equal to 3. And so, therefore, our equation is going to be f of x equals 3 times quantity x plus 1 plus 5. And that would be it. Next, your turn. Vertex of 3, -3, and point 2, -7, direction opening downward. Okay, pause the video, work it ahead, see if you can get this right. Okay, so h comma k is equivalent to the vertex. So we would say h is equal to 3 and k is equal to -3. And so in vertex form, that's going to be f of x equals a, which we do not know yet, except we know that a is going to be negative, times quantity x minus h, which is x minus 3 squared, minus 3. Now we can substitute in the point 2 comma negative 7. So here's our negative 7 in for f of x. And here's our 2 in for x. So we get negative 7 equals a times x, and x is 2, minus 3 squared minus 3. So we can just start working this through. We have negative 7 equals, and 2 times negative 2 minus 3 is negative 1, and negative 1 squared is 1. So we're going to have a minus 3 equals negative 7. We add 3. Add 3. Add 3. So a is equal to negative 4. So our function is going to be f of x equals negative 4 times quantity x minus 3 squared minus 3. So that'd be it. Okay, next. Explain to writing a quadratic function given the parabola's axis symmetry, direction of opening in 2 non-vertex points. This is that scenario B we talked about at the beginning. So here we're given a situation where we have a parabola opening upward as x equals 4 as the axis symmetry, contains the non-vertex points of 3, 5 and 7, 12. And so using your axis symmetry, we get this here. We don't have what k is yet. We don't have what a is. And so what we do is set up 2 separate equations using these different points. So the point 3, 5 will go place in here and work down and get eventually 5 equals a plus k. And then we'll take this other point, 7, 12, and work it over here on the other side. And it will eventually distill down to 12 equals 9a plus k. And now you have 2 equations with 2 unknowns, and you can solve. You can have these above the other. You can subtract. That would be pretty easy to solve. I'm not going to go into that detail right now. And then they go in this whole situation where you substitute in and find out what k is, find out what a is, and now you have your equation in vertex form. Now we have one of these fill in the blank situations. So I'm going to go through this pretty quickly. The parabola opens upward, has x equals negative 5. So x equals negative 5 gives the value of h in vertex form. So we substitute h, we have x minus negative 5 squared plus k. And here, working on the left side, we have this equation, and we're going to substitute that first point, which is negative 8, 7, and just working below, we have 7 equals, see, we have negative 3 squared, which is 9a plus k. 7 equals 9a plus k. So one equation, two unknowns. Now the right side, we can take this point 5 comma 20. So we have 20 equals a. That's 5 plus 5 squared. So we're going to get 10 squared. A times 10 squared plus k. So 20 equals 10a plus k. And so now from here, actually 10a, that's going to be 100a, isn't it? 10 squared is 100. 100a plus k. So now we have two equations and two unknowns. And this is what we have here. Solve the first equation for k. So this first one, we subtract 9a, so 2k in the second equation is solved for a. So I'm going to put that second in. Now we'll just go ahead and solve for a. And we have, just working below here, we have 20 equals 100 a plus 7, or 20 equals, and minus 9a, so we have 91a here. And then subtracting 13, or subtracting 7, we have 13 equals 91a. So a is equal to 13 91s. Okay, and on the right side, we have this thing simplifies here. Substitute a equals I got 13 over 91. That's 1/7. So now we substitute a equals 1/7 into the first equation, and we can work below 9 times 1/7 plus k equals 7. So k equals 7 minus 9 times 1/7. So k equals 7 minus 9/7. And 7 minus 9/7 is going to be 47, because that's going to be 49/7 minus 9/7 equals 47. So now we have what h and k are. So therefore the equation vertex form is f of x equals a x plus 5 squared plus 47. Okay, reflect. Given the axis symmetry in 2 points, what else can you immediately determine about the parabola? Well, we can determine the direction the parabola opens. I'm just going to go on here. Your turn. Write the equation in vertex form for a parabola that will satisfy the given conditions. Okay, the parabola opens downward, has x equals 6 as an axis symmetry, and contains the non-vertex points 15, 3 and 13, 6. We write our two equations. We have, I'm just going to write this standard form first. F of x equals a times x minus h squared plus k. And in this instance, we know we have x equals 6 as an axis symmetry. So we're going to have f of x equals a times x minus 6 20 squared plus k. Now we can just can work downward. We have, we're going to substitute in 15, 3. So we have 3 is equal to a, which we do not know yet. And we have x, which is 15 minus 6, 20 squared plus k. So we get 3 is equal to 5. 15 minus 6 is 9, and 9 squared is 81. So we have 3 equals 81a plus k. And now we're going to use this other point, 13, 6. So for this one we get 6. I'm just going to leave this on a same level here. We get 6. 6 is equal to a times 13 minus 6, 20 squared plus k. So 13 minus 6 is 7, and 7 squared is 49. So 6 is equal to 49a plus k. So what we have here is two equations, two unknowns. So the first thing we're going to do is we can just subtract one equation from the other. So I'm going to take this one here, put it right below. I'm going to put 6 equals 49a plus k, and I'm just going to subtract. So you have 3 minus 6, which is negative 3, equals 81a minus 49a. That's going to be 32a. And then k minus k is 0. So we have a is equal to negative 3 over 32. And now we can just use this equation up here to solve for k. So if we put 6 equals 49 times negative 3 over 32 plus k. And for that, we'll get negative 147 over 32. So 6 equals negative 147 over 32 and plus k. And how many 32s do we have in 6? Let's see, 32. 18, 198. So we get 198 sixths equals negative 32, excuse me, equals negative 147 over 32 plus k. So if we add 147 to both sides, we're going to get 345 is equal to k, 345 over 32. So let me see. 39. $343 should be 343. So well, that's not right. Should be 339. So it's 12. There we go. That's what that is. 12. Yeah, I'm going to get this right somehow. So we're going to get 339. So we're going to get our final equation to be f of x equals a, which is negative 332. We're going to have x minus 6 squared plus 339 over 32. Okay, and then we have modeling with quadratic functions. I'm not going to get into this one now. The video's already been more than long enough, but we'll get the exercise from here. Good luck, and thanks for viewing.